Alright, part 2, calculus 105, questions 37 to 72, 07, 06, 20. Find the derivative of ln of square root of that. Alright, y equals ln of that. Rewrite it, college algebra stuff. This is to the half power. Bring the half power in front, here, from college algebra formulas. Now, the derivative of this is going to be the derivative on top and the bottom. So, derivative on top or the bottom. Derivative on top is 2x plus 0 is 2x, and this is x squared plus 10. And you still have 1/2 of this, and the 2 cancels. So what's left is 1x over x squared plus 10, or dy dx is x over x squared plus 10. Evaluate the derivative of the function. So f of x is this. The formula is the sine inverse of f of x is f prime x over square root of this minus f of x squared. So f prime of x is derivative of the top, square root of 1 minus 7x5 to the second power. And the derivative of this is going to be 35x4 over square root of 1 minus 7x to the 5 squared. 7x to the 5, 7x5, this times this is going to give 49x to the 10. So it's f prime of x is 35x to the 4, square root of 1 minus 49x to the 10. Find the derivative of the function. Y equals tangent inverse of f of x. Y prime is going to be f prime of x over 1 plus f of x squared. So this one is going to be y prime is 3, derivative of the top over 1 plus 3x squared. The derivative of 3x is 3, so we have 3 times 3, which is going to give you the 9. So y prime is going to be 9 over 1 plus 3x squared, or dy dx is 9 over 1 plus 3x squared. Alright, next one. About the derivative of f of x equals cotangent inverse. So cotangent inverse is negative f prime of x over this squared. So f prime of x is the derivative of this one over this plus this one to the power 2. Derivative of e to the s is s, e to the s times s prime is 1. So e to the s times 1, that's going to be e to the s over, and then 2 times that is 2. So negative e to the s over 1 plus e to 2s. The size of a square increases in length at the rate of 6 meters per second. What rate is the area of the square changing when the sides are 15 meters long and when they are 23 meters long? Alright, so a equals s squared, that's a square. dA dt equals 2s ds dt. We know that ds dt is 6. Try 15 in there. So dA dt is 2 times 15 times 6, which is 180 for 15. What about when it's 23? dA dt equals 2 times 23 times 6 is 276. Find the equation of the line tangent to the curve at the point given point. At 412, find the derivative. Y prime equals 2x minus 0. Y prime is 2x. Y prime of 4 is going to be 2 times 4 is 8. So the slope is 8. Y minus y1 equals m times x minus x1. Point slope formula. So put the numbers in here. So y minus 12 equals 8 times x minus that. Y minus 12 equals 8 times that is 8x. 8 times that, negative 32. At 12, these are gone. So y equals 8x minus 20. Alright. At the time t, the position of the body moving along the x-axis is this. M. Find the displacement of the body from 0 to 3. So that means s of 3 minus s of 0. 3 times 3 times 3 is 27. 3 times 3 is 9. 9 times that is 81. 2 that times that is 22. 0, 0, 0. This is going to be 0. 27 minus that is 54 plus 72 is 18. 18 minus 0 is 18 minus 0 is 18. Use implicit differentiation to find dy dx for this. Well, this is going to be this one derivative, that one derivative, that derivative. But this is a product, like this. Fg prime first from last. X prime is 1 times y. X times y prime plus 1 equals 0. So now, xy plus xy prime plus 1. Bring these numbers. Other side, negative y, negative 1. Divide by x, divide by x. So we have y prime is negative y, negative 1 over x. Or take that negative 1 out, negative y plus 1 over x. Or dy dx, and you can turn these around if you want to. Negative 1 plus y over x. Find the derivative of the function. You have log base 4 of that. Well, you can have, just use this formula right here. First, let's rewrite it. This is to the half power, and the half power goes in front of college algebra rules. Now the derivative of this log base 4, which is this one here, log base b, whatever that is, it's going to be ln of b, f prime over f. So it's going to be 9x plus 3 prime. That's going to be 9 plus 0. It's going to be 9 over 9x plus 2 ln of 4 half. Well, so that's going to be 9 over 2 ln 4 9x plus 3. Or just 2 ln 4 9x plus 3 in the bottom, 9 on top. And there's the college algebra rules too. Boyle's law states that if the temperature of a gas remains constant, then PV equals C, where P is pressure, volume, C is constant. Given a quantity of gas at a constant temperature, if VC decreasing, this is negative, at a rate of 9, which is negative, at what rate is P increasing when it's 80 and 50? Alright, so dV dt is negative 80 and that. So this one, so we take the derivative of this. This is a product, F times G. So first one, that, plus last one. So PV, prime first, prime the last. So that's going to be P prime B plus PV prime. So now this is dP dt of V plus P times dV dt. So now, I'm going to go to part 1. Now we're going to go part 2. So we have dP dt of V plus that. Here's the numbers we're going to put in. Put these numbers here. That's 50. It's 80. That's negative 9. Equals 0. So that's going to be 720. Add 720, add 720. These are gone. So 50 equals this. Divide by 50, divide by 50. So dP dt equals this number. But 10 times that is this. So cancel the 10s. We're going to have dP dt is 72 over 5. Determine from the graph whether the function has absolute extreme values on A to B. Okay, A to B. Alright. So it does have absolute max is right here. That's the highest one of all of them. And it's included right there. So at letter D, at x equals D, there is absolute max. But these are open, so there is no absolute min. Find the critical points of the following function. So there's a function, derivative, 10x plus 3 minus 0, so that's 10x plus 3. Set 10x plus 3 equals 0, minus 3 minus 3, divide by 10, so x is negative 3 over 10. That's the critical point for that function right there. Find the critical points of the following. Alright, so let's rewrite it this way. Now this is going to be 3x squared, 9x is going to be 9. So this is 3 over 3, negative 1x squared over that. Negative 1x squared plus that, rewrite it. 9 minus x squared, that's going to be a squared minus b squared is going to be 3 times 3, x and x, 3 plus x, 3 minus x. 3 plus x equals 0, minus 3 minus 3, x is negative 3. 3 minus x means minus 3 minus 3, so negative x equals negative 3. Multiply by negative 1, multiply by negative 1, so negative is a positive. So x is negative 3, x is 3, critical points. Determine location and value of the absolute extrema, value of f on a given interval if they exist. Alright, derivative. F prime of x is this, negative 2x plus 0, so that's negative 2x. Set that equal to 0, divide by 2, x equals 0. Other critical, the endpoints, see right here, negative 3 and 4. What happens at f of negative 3 on the original problem? We ended up with a positive 3. F of 0, we ended up with a 12. And f of 4, we ended up with a negative 4. Well, the absolute max is right there. So at 0, it's 12. That's the max. And we ended up with negative 4. So absolute minimum is what? Negative 4 at this number right here. Stone is launched vertically from a cliff 384 feet above the ground at a speed of 32 feet per second. Its height above the ground t seconds after the launch is given by this formula right here from this interval. When does the stone reach its maximum? Okay, so take the original problem. Derivative is going to be 2t times that, 32 and 0, negative 32 t plus that, set that equal to 0, minus 30, bring the 32 over, divide by negative 32, divide by 2, so t equals 1. So now what happens? T, is that going to be the max? Just check this. So let's check a number here. S prime of 0 is going to give us 32, which is greater, increasing. S prime of 2 on this side is going to give you a negative 32, which is less than 0, so it's decreasing, so it's increasing, decreasing, so it's going to be a max right there. What number? At t equals 1. At what point is the conclusion of the mean value theorem hold for f of x equals x cubed under the interval negative 14 to 14? Alright. F of x is this, derivative 3x squared. So now, mean value theorem, there it is right there. Mean value theorem, there it is. So now, f of b minus f of a, but b is 14, a is the other number. 14 minus 14 over 14 minus 14 equals 3x squared derivative. So now 14 is this, negative 14 is this. So now we have this number minus over this equals that. Part 2. So we have this number and this number added together over 28 divided. 196 is 3x squared. So now divide by 3. I won't go in there. So take the square root. So plus or minus this number and this number. So now we have x equals this. But we can take the square root of that number is 14. But now multiply by square root of 3, multiply across, this and this will be square root of 9, square root of 9 is 3. We have plus or minus 14 square root of 3 over 3, or two answers. 14 square root of 3 over 3, or minus 14 square root of 3 over 3. Determine whether the mean value theorem applies to the function. Here's a take this function over this interval. The derivative of this is negative 2x. F of b minus f of a, b minus a, mean value theorem again. F of 2 minus f of negative 1 over 2 minus 1. So 6 minus 2 squared, 6 minus 1 squared. That's going to be 2 times 2 is 4, negative, positive. So you have 6 minus 4, 6 minus 1. Part 1. Let's go to part 2. So that's going to be 6 minus 4, 6 minus 1, 2 minus 5. It's going to be a negative 3 over 3, negative 1. Divide by negative 2, divide by negative 2, so the answer is going to be a half. Find the intervals in which f is increasing and the intervals in which f is decreasing. Take the derivative. So we have f prime equals this, f prime equals negative 2x. Set this equal to 0, divide by negative 2, divide by negative 2, x is 0. Now, let's see what's going on before 0, after 0, negative 1. F prime of negative 1 is going to give you this, which is 2, bigger than 0, it's increasing. F prime of 1 over here, negative 2 times that, negative 2 is less than 0, it's decreasing. So it's increasing, decreasing. So there's a max there, but anyway, it's increasing there from negative infinity to 0, and it's decreasing from there, 0 to infinity. Alright. Find the intervals in which f is increasing and the intervals in which it's decreasing. So let's take the derivative for this. Here's a function. Derivative is 0 minus that. F prime of x equals negative 1 plus 6x. Set negative 1 plus 6x equals 0. Goes are gone. 6x is that. Divide, you have x equals 1, 6. So now, part 1. So now, to the left, to the right, negative 1 and 1. Let's try those numbers back in the original. The derivative, f prime of negative 1 is going to give you a negative 7, less than 0, decreasing. F prime of 1 is going to give you a 5, greater than 0, increasing. So, increasing from 1, 6 to infinity, and decreasing from negative infinity to 1, 6. Locate the critical points of the following function. Use the second derivative test to determine whether they correspond to a local max or local min or neither one. Let's take the derivative of this. This is going to be negative 3x squared plus 30x. And the second derivative of this is going to be negative 6x plus 30. First derivative, second derivative. Set the first derivative equal to 0. Factor negative 3x out. So negative 3x equals 0, x minus 10 equals 0. So divide by 3, divide by negative 3, 0. Add 10, 10. So we have 0 and 10 are the critical values. So f prime, double prime of x, there it is. The first, let's put 0. 0, 0, 0 gets in there, it's going to be 30. Greater than 0 is concave up. That means there's a min right there. F double prime of 10 is going to be this numbers, which is going to be negative 30. Less than 0 is concave down like this. So that means there's a max. There's a min, there's a max. So minimum x equals 0. Maximum x equals 10. Look at the critical points of the following function. They use a second derivative test to determine whether they correspond to local max, local min, or neither. Take the derivative of this. It's going to be negative 6x squared minus 24x plus 0, or f prime of x equals negative 6x squared minus 24x. And the second derivative of this is negative 12x minus 24. So negative 6x squared minus 24x, let's factor that out. Negative 6x times that equals 0. Or x plus 4 equals 0. Divide by divide, so x equals 0. Or x is negative 4. Put them in there. F prime of 0 equals negative 12 minus 24. 0 minus 24 is a negative 24. Less than 0 concave down. Put a negative 4 there. Negative, negative, and that is going to be 48 minus 20. It's going to be 24. Bigger than 0, concave up. So there's a max and there's a min. So max at x equals 0 and a min at x equals negative 4. Use a linear approximation to estimate the following quantity. Choose a value of a to produce a small error. Alright, linear approximation. ln of this number, well, let's take f of x as is, f prime of x is 1 over x. So linear approximation is going to be 1.09 is f of 1 plus f prime of that number, and subtract those two. ln of 1 is 0, 1 over 1, because of this right here, put it in there, 1 over 1. So this minus this is 0.09, 1 times that is 0.09, 0 plus that, so approximation is 0.09. Consider the following function and express the relationship between a small change in x and a corresponding change in y in the form right here. So here's a problem. The derivative f prime of x is going to be 6x squared minus 4. So dy dx is rewrite it. Multiply by dx, multiply by dx. These are gone. So dy equals 6x squared minus 4 times dx. Evaluate the limit. Use the Hospital's rule when it's convenient and applicable. Well, it means this is what the rule means. If you have limit as x equals 0 of this function, the same thing as the limit as x equals 0 of f prime over f of x. And the derivative of y equals sine of x is going to be the cosine. So let's go from there. Let's see. Take the limit of this, take the derivative top, derivative bottom. The derivative top is going to give you 6 cosine of 7x, and the derivative of that is going to be 7. 7 times that is 42 cosine of that over this. Now, if you put 0 in here, what happens? You have 42 cosine of 7 times 0, that's 0. Cosine of 0 is 1. That's going to be 42 over 5. Use a calculator or program to compute the first 10 iterations of Newton's method when they are applied to the following function with a given initial approximation. Alright, I'm going to start here. There's the original function, x minus derivative is 2x, and we're going to start x of 0 is 5. So on the next page we're going to do to calculate all these numbers here. Alright, so x1 is x0 minus f of x0 over that. Well, that's going to be 5 minus f of 5 over f prime of 5, which is going to be 5 squared minus 23, 2 times 5. 25 minus 23 is 2 over 10, divide those two is 0.10. So 5 minus 0.10, 4.8000. Got this number x1. So now x1, we're going to use that number and put it in here. x2 is x1 and x1. So we have 48 minus 48 squared minus that over this. That's going to be 2304. 0.04 divided by 9.6 is this number. Subtract those two numbers, you're going to get 4.7958333. You can use a calculator to get the rest of those numbers over there. Alright, determine the following indefinite integral. Alright, here's the problem. There's a formula we're going to use. So it's going to be 9x to the 17 plus 1, 17 plus 1, minus 11x to the 21 over plus 1, 21 plus 1 plus c. That's going to be 18, 18, 22, 22, and factor it, 9 times 2. 22 times 11, these cancel, we're left with x 18 over 2 minus x 22 over 2 plus c. We added the following indefinite integral. Okay, let's rewrite this to a half power, and then bring it to the top, make it a negative half. This one, just make it a half, leave it like that. Use this formula again. So we have this to the negative 1 half plus 1, negative 1 half plus 1, 1 half plus 1, 1 half plus 1. This is going to be 2 over 2, 2 over 2. 2 over 2 minus a half is going to be half, half, and this is going to be add them together, it's going to be 3 halves, 3 halves. Flip this upside down, reciprocal, 2 and reciprocal. So now we have 2 times that is 20, x to the half, and 20 over 3, x to the 3 halves, and then we leave this alone, and we change this back to the square root symbol. 20 is square root of x plus 20 over 3, x to the 3 halves plus c. The integral of this one. Let's do it one way, using this formula right here. If you have f of x to the n power, the derivative outside, it becomes f of x to the n plus 1, or n plus 1 plus c. So the derivative of this part right here is 6. So I'll put a 6 there, and then 1 6 out here. Rewrite it. So 1 6 up. Now it's ready to go. 6x plus 5 to the 2 plus 1. 2 plus 1. That's going to be 3, 3. And that times that is going to be 1 over 18 times 6x plus 5 to the 3 plus c. Okay. Or another way, we can expand this one out. 6x plus 5, 6x plus 5. The second way. FOIL it out. 6 times that 36, that times that's 30, that times that's 30. So we have this. Now, integrate these guys. We're going to get 36x to the 2 plus 1, 2 plus 1, 1 plus 1, 1 plus 1. So 36x to the 3 over 3, 6x squared over 2. Divide, divide. So we have 12x cubed plus 30x squared minus 25x plus c. Determine the following indefinite integral. Let's just multiply it out. This times this is this times that is that. Okay, now we're going to use this formula. That's going to be 44m 3 plus 1, 3 plus 1, 40, m 2 plus 1, 2 plus 1. So that's going to be 44m 4 over 4, 40m 3 over 3, divide, divide, or 4 times 11 is this, cancel. That one I can't do anything with it. So this is going to be 11m4 minus 40m3 over 3 plus c. Determine the following indefinite integral. I'm going to use this formula again. To the third, to the negative 1/3, so plus 1 plus 1, plus 1 plus 1, 3, 3, 3, 3, these are ones. So 3, 3 over 1 is 4 thirds, 4 thirds. This is going to be 2 thirds, 2 thirds. Get the reciprocal of these guys up here. 3 over 4, and then flip this around. 3 over 2. So now, and this I can reduce because 2, 2 cancels. So we have 3 over 2, x to the 4 thirds. And this is going to be 9 over 2, x to the 2 thirds plus 11x plus c. We're done. This one. Determine the following indefinite integral. Integral of 4, 6 root of this, x to the 1 6, rewrite it, and then use this formula. Plus 1 plus 1, 6 over 6, 6 over 6, so that's going to be 7 over 6, 7 over 6, get the reciprocal of this, 6 over 7, times that. Can I reduce anything? Yeah, so that's 24 over 7, x to the 7 6 plus c. Determine the following indefinite integral. Let's just multiply it out. FOIL it. That times that is 28x, that times that is negative 7x squared, that times that is 4, that times that is minus 1x. Put them together, negative 7x squared, this one is 27, and the 4. Now we're going to use this formula here. Negative 7x to the 2 plus 1, 2 plus 1, that's 3. And this one 1 plus 1 is 2, 2, so 27x squared over 2 plus 4x plus c. Determine the following indefinite integral. So let's just break it up in two fractions. Now, can I divide this? Yes. Subtract this power from that power. That's going to be 3. This power from this power. That's going to be 2. So now, this right here. Using this formula. 4x cubed. And it's an x squared. 3 plus 1, 3 plus 1, 2 plus 1, 2 plus 1. That's going to be 4, 4. Can I divide these numbers? Yes. This divides this x to the 4th minus 3x cubed plus c. For the following function of f, find the antiderivative big F that satisfies the given condition. So f of x is this, and big F of x is going to be the integral of all of that with the condition right there. And that's going to give 4x to the 3 plus 1, 3 plus 1, minus 5 cosine of x. So now, this divides 4, yes, so you have f big F of x equals x4 minus 5 cosine x plus c. We have an initial condition right here. Big F of 0 is 0, and then 0 plus c equals 2. 0, 0, 0, 0, all these can be 0, minus 5 plus c equals that. So minus 5 plus c equals that, minus 5 plus 5, these are gone. So 2 plus 5 is 7, so c is 7. So that means this right here is really going to be f of x is x4 minus 5 cosine of x plus 7 for the c. Given the following velocity function of an object moving along a line, find the position function with a given initial condition. There it is. So integral of this is going to give me the s of t equals integral of this side. So that's going to be 3t 2 plus 1, 2 plus 1, right here, 1 plus 1. That's going to be 3t cubed over this and that one. So that reduces to t cubed, 3t squared minus 5t plus c. But we have this condition here. So s of 0 is 0, 0, 0, and equals that. 0, 0, 0 plus c, so c must be 0. So this formula becomes s of t is t cubed, 3t squared minus 5t, and the c is 0. You don't need it, just that. Find the absolute extreme values of the function. There's the original function. There's the interval sum from -8 to 64. We need to look at these points too. So now, I'm going to use this formula right here. So f prime of x is x to the 1/3. Rewrite it. 1/3. 1/3 minus 3/3. -2/3. Rewrite this as 1 over 3x to the 2/3. And notice, it's undefined if x is 0 right here. You have this over 0. So there's one point. We also need to consider that point and that point. So we have -8, a 0, and a 64. F of -8 is cube root of -8, -2 times -2, -2, so all these cancels, we have -2. F of 0, cube root of 0, 0 times 0 times 0, 0. F cube root of 64, 64 is 4 cubed, cubes and cubes are gone, you have 4. So we ended up with -2, 0, and 4. So the absolute max is at 64, 4. And the absolute min is at -8, and we had it at -2. So that's the min, absolute max, absolute min. And we are done with this part anyway. Thank you. Sorry about that. All right.